Today our lesson is on special right triangles, and we're specifically going to focus on special right triangles that have angle measures of 45, 45, and 90-degree angles. Right? And this is an isosceles right triangle. If we have a right triangle, we know that that's 180 minus 90, so we have 90 degrees left over. And if we cut those 90 degrees in half, we get 45 degrees. So that means that this is 45 degrees, and this is 45 degrees. And if we have a right triangle that has two congruent angles, then we also know those sides are congruent. Right? Now, if we have information about the sides, we can always use the Pythagorean theorem. But when we have a special right triangle, or a triangle that we know is an isosceles right triangle with 45, 45, 90-degree measures, we have shortcuts that can help us, that allow us not to use the Pythagorean theorem. Right? The shortcuts might seem confusing at first, but the more you practice them, the shortcuts will be shorter than using the Pythagorean theorem. So the shortcuts are in relation to the sides that are across from the angle that we're talking about. So across from the 45, 45 angle. Right? So if we look at the side that's across from the 45, that's represented by x. And since these sides are congruent, across from this 45-degree angle can also be represented by x. And finally, the last side, which is the side that is across from the 90-degree angle, is represented by x, the square root of 2. So if you know x, then you know all three sides. And this allows us to find the measure of the three sides without using the Pythagorean theorem. So again, another way to look at this is to have your 45 is represented by x, a 45-degree angle is represented by x, and across from the 90-degree angle is represented by x, the square root of 2. This is pretty much the formula or the formulas that we're going to use to help us solve our special right triangles. So make sure that you pause the video and have this written down in your notes before we move on to the practice. So here we have an example of a triangle. It's a right triangle, and we know that one of the angles is 45. We know that the side is 7, and we're trying to find the value of Q. So we want to find Q. Now, Pythagorean theorem would work for this. We could use a squared plus b squared equals c squared. But if we happen to recognize that this is a special right triangle, a 90-degree angle with a 45-degree angle means that this other angle has to be 45 degrees, and we have our special right triangle. So to get started, we can write our formulas out. We know that across from the 45-degree angle is represented by x. Across from the other 45-degree angle is also represented by x because these are congruent. And lastly, our 90-degree angle is represented by x, the square root of 2. So we want to look and think, what information do we have? We're trying to find the measure that's across from the 45-degree angle. We're looking for Q. So this is what we're trying to find. What information do we know? Well, we know that across from the 45-degree angle, we have this side measure, which is 7. So our x is equal to 7, which means that this x is also equal to 7. So across from this 45 is going to be the measure of 7. And we know that because this is an isosceles triangle, so the two sides have to be the same. Now, how do we find the value of Q? Well, if we know x is 7, then we also know that this x is 7. So all we have to do is simply substitute that value in and we found the value of the side across from the 90-degree angle, or our hypotenuse, which means that Q is going to be 7 the square root of 2. Because again, we're taking our x, which we found using the 45 side, and we substituted it in for the value that's equal to our 90. So Q is 7 root 2, which is exactly what you would have gotten if you had done the Pythagorean theorem. One more example. Here again, we have a diagram. We can see that it's a right angle, and we see that we have two unknown sides, but they're both being represented by the same variable, which means that our sides have to be the same, or that our sides are congruent. And if our sides are congruent, we know that our angles must be congruent, and since we have a 90-degree angle, our angles have to be a 45-degree and a 45-degree angle, which is our special right triangle. So we can use our properties. Again, 45 is going to be represented by x, 45 is going to be represented by x, and 90 is represented by x to the square root of 2. We are trying to find the sides that are across from our 45-degree angle. So this is what we're looking for. So we need to find our x. And in order to do that, we're going to have to use the information that's across from our 90. 90 again is represented by x to the square root of 2, which we know is equal to 3 the square root of 2. So we can use this equation to help us find our x. If I have x to the square root of 2 is equal to 3 the square root of 2, and I want to isolate my x, what do I need to do? Well, I need to get rid of my square root of 2. And I can do this, because this is x times the square root of 2, by doing the inverse operation on both sides, which is dividing by the square root of 2. Square root of 2 over square root of 2 cancels to 1, so x is 3, because on this side as well, the square root of 2 over the square root of 2 simplifies to 1. So my x is 3, and again, just by solving for my x, I found that the side across from the 45-degree can be just simply x, so I know that my m is equal to 3, and this m is equal to 3 as well. Make sure you have these examples as well as the formulas in your notes so that you can have this to go over practice when we get back to class.